I hope you're ready for some tech talk because we are about to get a crash course in motorized spindle design, motorized spindle technology. And with me is Sam Lee, Solpower's International Sales Manager. Sam, thank you again for having us today.
The pleasure is all mine. Thank you. Thank you.
And we want to talk about motorized spindles because it is one of your core products, one of your core technologies, right?
Of course, yes. Yes, it is.
Okay, so obviously people watching, most of them will be from the machine tool industry, so they will be familiar with spindles, but maybe more familiar with conventional spindles such as belt-driven spindles. Yep. So to kick it off, why don't you give us the main differences between a conventional spindle and a motorized spindle?
Okay, well, let me tell you. The conventional one has an external motor which depends on the gear and the bolt and the calipers. But the motorized spindle, the motor itself is built inside.
Okay.
Yes.
Hence the name built-in motor or built-in spindle or motorized spindle.
Yes, absolutely, yes.
And we'll be talking about the benefits of motorized spindles in more detail, but from what you just said, I would assume a clear advantage is you save some space, right? Because you don't have a motor attached.
Yes,
outside.
Absolutely, yes. Okay,
absolutely. Excellent. Now we'll be talking about the spindles here in a few moments, but we also have some components here, components of a motorized spindle. So what are we seeing here in front of us?
Well, yeah, this is just a few components. The motorized spindle itself has a lot of components, but generally speaking, the most important part are the shaft itself, the spacer, the encoder, and the bearing, front and back, rear bearing, yes.
And of course we could get here into even more details, but we're not engineers, you're not an engineer, so we're trying to get some of the most basic facts.
I'll try my best, yes. I'll try to highlight
beautiful.
some. Yes.
Now the spindles, so we see three types here in front of us to illustrate the different applications, so
of
maybe
course.
you can share a little bit.
Yes, where the main application are here at Solpower, the milling.
Okay, so that's a milling spindle for milling applications.
Yes, and the turning built-in spindle.
Okay.
And the woodworking.
Oh, okay. Also for woodworking.
Yes, absolutely. Built-in motor. Yes.
Okay. Now I just mentioned benefits of a motorized spindles. We talked about saved space, but there is more. So why don't you give us the main advantages of a motorized spindle compared to other spindle types?
Okay. Well, the main advantages are high speed.
Okay. Higher speed.
High precision. Low vibration. Very small size and very easy to install.
Okay.
Yes.
Okay, great. I mean, we'll be talking about all those things in more detail in a few moments, and we'll also see some inspection processes, some inspection equipment, QC, QA measures, and so on. But of course, quality starts at the very beginning, the very beginning is the design process. So, and you manufacture and design your spindles 100% yourself, right?
Absolutely, yes.
So that's why we want to focus on the design process. And you are not a designer, again, I just said it, but
just highlighting.
But
I'm trying to highlight.
Go through the main steps of your design process right now.
Sounds good. Sounds good. Okay.
So,
well, let me start with the heart of the motorized spindle.
Okay.
The motor itself. It's made in-house. We made it here at Solpower.
Oh, okay. So even the motor itself is manufactured by Solpower.
Absolutely.
You're not using
for the past
motors from other manufacturers.
No. For the past 25 years, we have been manufacturing the motor itself.
Okay.
Yes.
It's one of your core technologies, motors.
Of
right?
course, yes.
That's how Solpower started out,
Oh, yes, we started,
as a
building
the
motor supplier, yes.
So how do you want to show us and tell us about that design process?
Okay, well, let's start off with taking a look at one of our motorized spindle.
All right,
yes.
Let's do it. Okay, so we're seeing a specification sheet of one of your spindles.
Yes, this is one on our catalog. Yes, our customer can find it, of course, on our page.
Okay, so one of your motorized spindles, that's what we're talking about today.
Yes, exactly, yes.
So, what do we see? What do you want to tell us?
Well, before we start building the prototype, manufacturing the prototype, we have to determine three things. The first one is the interface, the housing. How big is it in terms of size?
Okay.
And the second thing, we have to know the maximum speed of the motorized spindle.
So the requirements of your customer, what requirements does it have?
Yeah, we have to determine that. Yes, of course. Yes.
Spindle speed. All right.
Yes.
That's 24,000 RPM. That's pretty fast, right?
Actually, not that fast when it comes to Solpower. Yeah, we can reach up. We already reached up to 40,000.
Oh wow. Okay.
Yes. So it depends on the taper, and of course depends on the customer requirement. The third thing we have to determine before we start the prototype or the bearing calculation procedure, what kind of tool system we're using.
All right.
Yep. As you see here.
So we've got all those parameters, and say I need a different diameter, different maximum spindle speed, and most of these parameters can be customized.
Absolutely, yes. Absolutely, yes. The housing, the speed, the bearing specification. I mean, the lubrication, it's grease.
Right.
Some customers required oil air.
Okay.
See here, the built-in motor. Some customer required a synchronous, some customer require synchronous.
Okay, so again, different types of motors
of course,
as well.
As
we talked about the motor, you said the heart of the spindle, and we also have a spec sheet for a motor, right?
Yes, of course. Well, I have to specify something here. You will never see this kind of specification of a motorized spindle in any other companies.
Oh, okay. Why is that?
For one reason.
Okay.
Because we made this in-house. The motor. Inside the spindle, yes.
I see. So that's what, maybe we talked about it already. You manufacture your motors 100% yourself as well. It's built in-house.
Yeah, so those are customized. Even here, the torque, the shaft power, the shaft speed.
Okay.
It's also can be customized and up to the customers to decide that.
Okay,
yep.
Great. So that's the very first step of the design process, just determining what do we need. What kind of specifications do we require?
Of course. Okay, well, after that, we'll make an initial blueprint of the bearing calculation procedure. Here you go. As you see, the first thing is the structure of the spindle. The second thing, we add the maximum speed.
Right.
We'll add the DMN value. We at here at Solpower, we can reach up to 200.
Okay.
And the mounting direction here is vertical. Of course, it can be horizontal as well.
All right.
The lubrication here in grease, but of course, we customize oil air as well.
Yeah.
Here we use
more design parameters.
Yes.
Okay, so what else do we want to focus on this chart?
Here we entered the interference value between the inner bearing, the inner rings of the bearing, and the shaft.
All right.
And the second here, it's the clearance between the outer ring, ring of the bearing, and the housing.
So this is obviously tolerance. We're talking about accuracy.
Yes, interference and clearance as well. Yes, as of course we get those, which was most importantly to get these, the spindle rigidity. And as you know, the rigidity in the spindle, it's
absolutely
the most
crucial,
one of the most important factor here.
Yep.
Axial or radial. And those diagrams, it's
so those are calculations, what you expect from this spindle performance.
Yes, you can say so, yes.
Okay.
And here we
spacer. Okay.
Yes, we use the correct amount of the spacer data to do our preload adjustment. So here, the inner ring, the interference between the bearing inner ring and the shaft. Here we'll know the correction amount data of the spacer ring which needed to be grinded.
Okay, and we can see very low tolerances, like very high accuracy.
Of course, that's one of the main advantages of the motorized spindle. So here, as you see, when the outer ring of the spacer is higher than the inner one, the preload increases.
Okay.
And here, when the outer ring of the spacer is lower than the inner one, the preload decreases.
Okay, so that's like the basic, when it comes to the spacer, the basic thing that you have to pay attention to.
Yeah, absolutely. It's kind of an overview of the blueprint.
So when it comes to the very first stage of the design or the design process itself, those were the basic calculations that you have to perform.
Yes. It's a must. Yes, of course.
Okay, and then the next step would be before the production, you would manufacture a prototype.
Absolutely, yes.
Okay,
well,
so
we can talk about it more here.
Yeah, of course. Let's do that.
Okay.
So we talked about the components earlier already, shaft, spacer and whatnot. And so how do you make sure that whatever design, drawing, calculations and all that theoretical stuff, you have the spindle that you want to manufacture and then you have the prototype. So how do you check the quality of these components to ensure that the spindle performs as expected?
Well, the inner parts of the motorized spindle are very, very important. We focused on the precision of it. Has to be ultra precision. Let's say the shaft, the spacer, etc. So we use like many devices and instruments, such like the roundest device detections, and 2D, 3D inspection instruments. Of course, to measure the deflection, the roundness, and the cylindricity. And regarding the spacer ring, well, of course, we focus on its parallelism.
So roundness testing, parallelism, and 3D coordinated measuring.
So on.
So you've got all that equipment here in-house.
Yes.
So you have the capabilities to perform those inspections.
Absolutely, and I can take a look later on.
Yeah, we will in a few moments, and we're going to split it up because you have like two big areas when it comes to testing as well. One is dynamic measurements and static measurements, right?
I think we have another, the run-in and the climbing as well. Measurement, yes.
Right, so and do you want to show us some of the testing right now? Can we just check it out?
Yeah, let's start with the dynamic measurement.
Okay,
please.
Okay, let's go.
Let's go. One of our first item on the dynamic measurement testing.
For motorized spindles.
Yes, temperature saturation process, aka run-in.
Run-in test.
Yes, run-in test. So here we monitor and record the temperature rising stability from 0 to its maximum high speed, RPM.
So
by adding 1000 RPM each time until we reach its highest rotation speed, highest RPM.
Incremental steps, and at each step you will measure the temperature.
Absolutely, yes. As you see here, it's the temperature degrees. The maximum is 60. And here is the line, it's a timeline. And there is the revolution per minute,
so
the RPM, spindle speed, till we reach its maximum.
Got it.
And under normal circumstances, won't exceed 30 degrees.
So that's the goal.
Yes, of course. And we have to record every step all the way. All
right, so that was the run-in test, but that's only one of 4 items, I believe, on the dynamic measurement list, right?
Yes,
so
exactly,
what's up next? What else do we have?
The second thing I see here is the frequency measurement.
Frequency?
Yes, the frequency analysis is to measure the spindle operation. So we'll make sure that the spindle rotation is perfectly good. As you see on the screen, when it's first, second, third order are gradually decreasing, that means the spindles are perfectly good.
Perfect. Solpower quality.
Absolutely, yes.
Beautiful. Now also another important topic, we want to talk about vibration. You want to keep it low,
of course,
because it's very important for the accuracy as
It's one of the main advantages of the spindle, actually, to have a low vibration. So on our measurement here at Solpower, our vibration measurement are based on ISO 17243.
All right.
So
again, international standard.
Absolutely, yes. It's the highest international standards for the vibration. The rotation speed here starts from 600 RPM till 30,000 RPM.
Oh wow! All the way up to 30,000.
And it's also suitable for roll-on bearing and ball bearing as well.
Excellent. So vibration testing. Now we have one more item on the list when it comes to dynamic measurements.
Balancing, I believe.
Balancing. So we want to keep the spindle well balanced.
Of course, yes. It's to integrate the central line of mass with rotational axis.
Okay.
Yeah, so we'll have high accuracy and a better surface finish.
Okay.
And a higher removal rate.
Okay.
And to increase, of course, the tooling life as well.
Okay, so 4 things you just mentioned. I'm sure people who are looking for a motorized spindle that will very much care about,
yes,
right?
it's one of the main advantages of the motorized spindle itself.
Okay.
Yes, to be very high accurate, high precision.
Okay, and again, I think here you're also testing according to ISO standards, right?
Yes, our balancing inspection here at Solpower is based on ISO 1940.
Okay, so again, meeting international standards?
Yes, absolutely, yes.
Okay, okay.
Actually, the mechanism behind the motorized spindle, as you already know and our audience know, it's very complicated.
It is indeed.
So, yeah, most of our dynamic measurement has to be done twice.
Okay.
So, yeah, we have to make sure there's no space or place for error here.
Okay, so meeting 100% quality.
Absolutely, 110%.
110%.
Yes, okay, 110, excellent. Yeah.
So that was the balancing, the last item on our dynamic measurement list.
Yes.
But now we want to move on to the static measurements.
Yes.
And I believe we have to go to another area.
Yes.
Okay, you want to take me there now?
Yes, please. Yes,
okay,
let's go.
Let's go. All right, Sam, so we just covered dynamic measurements and now we want to talk about static measurements, right?
Of course, yes. We're going to start talking about static measurement first, then clamping force, then we'll end up with, eventually, with the run out.
Run out, okay.
Yes.
Okay, so static measurements, what do we need to know about?
Well, at Solpower here we have to focus on 2 points, 2 things. The axial rigidity and the radial rigidity.
Okay, axial and radial rigidity.
Yes, these are very important.
Right, obviously rigidity is very important, right?
Because it has to do a lot with the quality of the workpiece you're working on. So those inspections, the axial and the radial has to pass our measurement.
Okay.
Yes, in order to ensure our customer that he can get the quality he required.
Yeah, that's the main target, that's the main goal.
Of course, yes.
Okay, so what else do we have?
We have the clamping force.
Okay.
Besides testing the clamping force, we need to test the draw bar and endorsement.
Okay.
Besides the draw bar, we have the axial thermal growth of the shaft.
Thermal growth of the shaft. Okay.
Yes, the axial.
Very technical,
Of course, yes, because we have to ensure the quality of our motorized spindle, our built-in spindle, in order to get to the best quality we can achieve, we can get.
Okay, wow, I mean, we just talked about the dynamic measurements, then now the static measurements and additional tests, additional inspections. So altogether, I think like 10, 11, 12 different inspection procedures for your motorized spindle.
Well, I stopped counting one time ago.
Yeah, well, I mean, I don't know how many, but there's quite a lot, and I think there's even more that you want to talk about,
the mechanism behind that is very, very wide.
And another thing that I think that you mentioned earlier is the run-outs.
I think there's a run-out still, yes.
Yeah.
Okay, finally, we're going to be talking about the run-out.
Okay.
There is our 4 position to measure before shipping out the spindle itself.
All right.
The taper, inside the taper, we have to measure the accuracy. It should be, and actually it must be, less or equal to 0.002 millimeter.
Okay.
And the second position, it's the taper face itself, outside. We have to measure it, the same thing.
And the tolerance there?
0.002 millimeters.
Okay, same.
So the third position we have to test is the root of the test bar, which has to be equal to 0.003. Then the fourth part, we have to test the test bar itself, run out, which has to be equal to 0.008.
All right.
Yes.
Okay, so that was that inspection.
The run out.
The run out inspection, right?
Yes.
Okay, so thank you, Sam, for showing us dynamic measurements, static measurements, and all the other inspections. But there's even more. There are some inspection procedures that you couldn't or wouldn't show us, right?
Well, yes, it's a policy. There's some customized machine. Yeah, made for Solpower. So
not meant for the public.
Absolutely, yes.
Okay, beautiful. Yeah. So I think we're done here, but I know that you want to share even more with us today about
Yes.
your capabilities when it comes to the manufacture of motorized spindles, right?
Absolutely. What about we go back to where we started?
Okay, let's go.
Let's go.
Okay. Wow, so we've just seen what really goes into the design, the manufacture, the development of a motorized spindle, right, Sam? We talked about the design process, we talked about all the calculations that you have to perform, and then all the testing, all those inspections we've just seen. So it's not an easy task to develop, to manufacture a motorized spindle.
Of course, that's why the main advantages of the motorized spindle, the high precision, the high speed, the low vibration, and compact size, and easy to install, as I mentioned before. So it has to be ultra precision. To do that, yes.
And if you want to achieve ultra precision, you need the knowledge and you need a big team, right? You have a huge R&D team as well.
So we have like almost about 30, 35.
Wow.
Yes,
okay.
with over than 20. Yeah, with over than 20 years experience in this field.
Okay, excellent.
Yeah.
Now we want to talk about, obviously, you're not the only manufacturer of motorized spindles here in Taiwan. But I am sure, Sam, that you believe that you are the #1 choice for everyone around the globe looking for a professional motorized spindle supplier, right?
Absolutely, yes. I mean, believe is not enough here to describe Solpower.
Okay.
I'm very confident that we are the best choice.
Okay, so what makes you so confident about it? What are the main advantages of Solpower's motorized spindles?
Well, besides the fact we have seen Solpower's manufacturing competitive capabilities, we have been in this business for the past 25 years, manufacturing motors and the spindles part. And Solpower is holding one of, most of the well-respected certificate. Such as ISO 1940, ISO 17243, UL as well.
Wait, UL, are we talking about UL certified or UL recognized or UL listed? I mean, I think there are some slight differences there, right?
Yeah, good questions. Well, we are a UL listed. We have been testing nationally for the safety and sustainability standards.
Okay, safety and sustainability, also two very important topics. Now, Sam, before we end this segment here, anything else you would like to add?
Absolutely, yes. I want to add the most important thing I've been thinking about since we started.
Okay, please go ahead.
Yes.
We're listening.
Well, Solpower is the only manufacturer here in Taiwan who has these capabilities.
Okay, when you say these capabilities, you're talking about manufacturing motorized spindles in-house?
Actually, the motor itself is the heart. So Solpower have been manufacturing the motor since 1995, and Solpower motor globally well known. So from starting from the motor itself till we manufacture the whole part of the motorized spindle. So there is no need to go to B or C or D to manufacture or to get your motor to put it inside.
Okay, so that's not Solpower. You don't see yourself as B, C, D, E.
We're not in a B, C, and a D. We already proved ourselves enough to be an A.
Okay.
There is none in Taiwan who can manufacture the motor synchronous asynchronous and manufacture the spindle from A to Z here in-house, except Solpower.
Okay, excellent. I like your confidence, Sam. Thank you very much for this crash course on motorized spindles, and thank you for watching. If you're looking for a supplier that can help you with the manufacture of motorized spindles from the beginning to the very end, the design, research of the spindle and the motor itself, testing, prototyping, manufacture and after-sales services, well, then Solpower might be the best choice for you.